Hey everybody, your Friendly Math Tutor here with part B of our MCQ practice test that we're going through. So you can check out the other video where I go through the 30 multiple choice questions from part A, where we don't use a calculator. And here we are in part B. We've got 15 multiple choice questions where we might not use calculator on everyone, but calculator is available. So we take a look at number 31, and the way that I'm going to do this one is I'm going to start with the ratio test. So one thing I know is that the way the ratio test works is if I take the limit as n goes to infinity of the absolute value of a sub n plus 1, so I get -1 to the n plus 1, and then n plus 1 factorial, and then x to the n plus 1. All over n plus 1 to the n plus 1. And I'm going to divide that by a sub n, which really just means I'm going to multiply by the reciprocal of a sub n. So I get n to the n over -1 to the n factorial x to the n. And I want all of this to be less than 1 because that's the outcome we need for the ratio test. We need that limit to be less than 1 in order for it to converge. Now I'm going to find the radius of convergence. So a couple things. These -1s, they end up dividing out to be -1, but I don't really care because I'm taking the absolute value anyway, so I'm just going to ignore them. And then what I have is all the stuff that I pull out with n's. I don't need them in the absolute value because the n's are all positive to begin with. We're going from 0 to infinity. So n plus 1 factorial over n factorial. The n factorial cancels and just leaves us with n plus 1. And then that n plus 1 that's left, that's n plus 1 to the first, I can divide that out with this n plus 1 to the n plus 1. And if I subtract the exponents, I just get n plus 1 to the n. So this kind of like divides out that way. Now so then this and this become n over n plus 1 to the n. I'll get to that in a second. Now, if I do x to the n plus 1 divided by x to the n plus 1 minus n is 1. So I just get n plus 1, minus n is just 1. So I get x to the first, absolute value, because x could be negative, less than 1. So now what I'm going to do is I'm going to focus on this limit right here. So that should look familiar, hopefully. It's based off of this limit. So this is something that we know. So what I'm going to do is I'm going to do a little bit of work on this over here. I'm going to say it's the same as if we flip this, we get n plus 1 over n to the -1. So that to the -1, and then all that to the n. So notice I haven't changed anything because I flipped it, but I raised it to the negative first power. And then if I do n over n, that's 1 plus 1 over n. All of that to the -1, but then these get multiplied, which means they're allowed to just change places because it doesn't matter which way you multiply them because multiplication is commutative. All right, so what I now have is this limit. This is like the definition of e, right? That's what this says down here. So this limit is e, but to the -1, and e to the -1 is 1 over e. So this whole thing becomes 1 over e, absolute value of x is less than 1. Then I have absolute value of x is less than e. And when you get it in this form, the value that's over here is the radius of convergence. So it ends up being c. All right, so just to refresh, that is when you have absolute value of x minus c is less than r. That r is the radius of convergence. And here our center is 0, so we have that set up. So e is going to be the radius of convergence. All right, pretty challenging problem. The reason I use this is because the other way to do it would be to have to use like L'Hopital's rule, and it's a lot more work in my opinion. All right. Let's move on to number 32. So we have a composition of functions, and using the table, what is the approximate value of the derivative of h of x at 1.35? So let's first find the derivative of h. So h prime of x is going to be the chain rule. So we have f prime of g of x times g prime of x. And then if I want to find h prime of 1.35, that is f prime of g of 1.35 times g prime of 1.35. And then that is, so it's g of 1.35 is just 2.7. So now we're doing f prime of 2.7, and then g prime of 1.35. They don't give us that. So oh, but they do give us, my bad. They do give us f prime. I was looking at that wrong. They give us f prime of 2.7. That's 3.97. Now, this is how we're going to do this. And the giveaway is when they say, what is the approximate value? If they wanted the exact value of the derivative, then we would be able to find that. But approximate value means we're going to be using average rate of change to approximate instantaneous rate of change. So what we're going to do is we're going to look at it kind of like algebra 1 slope. And if it's with the g function, we're going to use the point after and the point before. So I do change in y, so 2.9 minus 2.5, which is 0.4. And then the change in x is 1.4 minus 1.3, which is 0.1. And when you divide those, you just get 4. And 4 times 3.97 is 15.88. So you just throw all this in the calculator. This is a calculator. So that's A. All right, so the table gives us f prime directly, but it doesn't give us g prime, which is where the approximation needs to come in, and that's where we do the average rate of change as opposed to instantaneous rate of change, because we can't do instantaneous rate of change. All right, on to number 33. So if f is an antiderivative of that, okay. So this is one where they want us to use the fundamental theorem of calculus. So the way I do it is I take the integral of sine squared x over x squared plus 2 from 0 to 2 dx. And if f is the antiderivative of this, that should equal f of 2 minus f of 0. This is the fundamental theorem of calculus. The antiderivative is usually capital F, and it's capital F of A minus capital F of B, but in this case, little f is just the antiderivative. Now, we know that f of 2 is 1/2, and f of 0 is the thing that we're solving for. So what we're going to do is to find this. This is a calculator problem. So I'm just going to do that in Desmos. So if I slide on over to Desmos, if you type in int, that gives you the integral symbol. So just a little shortcut there. And we're going from 0 to 2. And then we're making a fraction. And then I'm going to do sine of x quantity squared. And then on the bottom, I have x squared plus 2. And then make sure you put your dx, and you get your answer, 0.3252. So 0.3252. And then I'm going to just rearrange to get f of 0 by itself. So I'm going to add f of 0 to this side, and then I'm going to subtract this. So I have 1/2 minus 0.3252. You can just throw that back into Desmos or just use like your TI-84, but that ends up being 0.175, which is answer choice B. All right, so a nice solid fundamental theorem of calculus combined with Desmos to actually evaluate the integral, which is way too complicated for us to do by hand. So don't evaluate any integrals on the calculator section. Just throw it into Desmos. All right, on to number 34. We want the length of the curve given parametric equation. So one thing we need to know is that is the integral from t1 to t2 of the square root of x prime of t squared plus y prime of t squared dt. That is just our derivative. Or sorry, that is just the arc length formula. So there's several of them. That is the arc length formula for parametric equations. So I think what I'm going to do is try to let Desmos do as much of this as possible. So rather than finding x prime and y prime, let me see. I'm going to show you how you can do this. So we're going to hop back over to Desmos, and we're going to define x of t as cosine of 3t. And we're going to define y of t as sine of t cubed. Then we're just going to type in that integral. So we're going to do the integral. And this one said it was pi, so pi is pi. And then we can do 3pi for 3 pi. And then we're going to do sqrt to give us the square root. And I'm going to do a parentheses, and I'm going to put x prime of t, and then I'm going to square that. And then I'm going to do plus, then parentheses, y prime of t, and I'm going to square that. And then I'm going to do dt. It looks like that is not working. All right, that is. So that was my fix real quick. So it just didn't allow for x and y the way it's defined here. So I just changed it to f and g. All right, so hopefully that made sense. So we just called the first one f, but it just does it for you. The whole point, what I was trying to do was to have it not have to take the derivative myself, to be able to define it and then use Desmos to do the derivative just within the formula. So it's actually just something that now I feel like I knew that. I just didn't, I kind of forgot. We want to define functions like f, g, h. You want to use x and y. It gets too confusing, I guess, with what it's used to doing with x and y. But we can use t. So again, define the first one, use f, second one, use g, and then just use the formula. All right, so the answer was 13.26, which is B. Okay, so the function sine x is defined. The line tangent to the graph at x equals 1.513 is parallel. They didn't spell parallel right there, but that's fine. To the segment connecting the endpoint of 0 to b. What is the value of b? So basically, this is kind of like mean value theorem. So the slope, if two lines are parallel, then their slopes are equal. So the slope of the line is just going to be sine of b minus sine of 0 over b minus 0. And we know that that is equal to the derivative evaluated, all right? So the tangent line is the derivative. So that would be the derivative of f of x is cosine x. So that would be equal to the cosine of 1.531. So this is just sine of b minus 0. So it's just sine of b over b equals whatever the cosine of 1.531 is. And then we're just going to hop over to Desmos. I don't know. I mean, we probably could have had Desmos like take the derivative for us. But the derivative of sine is cosine. That's so like straightforward that I didn't do Desmos for that. So now what I'm going to do is just go over to Desmos and just plug that in. But instead of b, I'm going to use x. So I'm going to do sine x over x is equal to the cosine of 1.531. And then my answer has to be between well, actually, I just find the first answer. So if I look, it's a number a little bit bigger than 3, like not bigger than 3.5, though, so just a little bit bigger than 3. And if I look at my answers, that's clearly D. All right, so again, just to refresh, in Desmos, just real quick, like when you put in an equation with x's here, it graphs the vertical lines. All right, and if you look, there's a bunch of vertical lines, but the only one that matches the answer choices is this one that's a little bit bigger than 3. Whoops. All right, let's keep going. So we take a look at 36, and so the way that I'm going to do this one is, hopefully, one thing that's really important that we know is anytime you have a differential equation that looks like that, the solution to it is y equals p e to the kt, where p is your initial value. So what I'm going to do is I'm just going to solve for k. All right, so there's really no calculus here. So initially there were 500,000, so that's this number. And then 10 days later, there was 100,000. And then I'm just going to solve this. This one, I think I'm going to solve just right here. I'm not going to use Desmos. I'm just going to use a TI-84. So when you divide these, you get 1/5 equals e to the 10k. And then we have ln 1/5 is 10k. So then ln of 1/5 divided by 10 is equal to k. And then I'm going to go up here, and my equation is going to be 500,000 e. Then we're going to get k, so I'm going to do that. I'm going to do the ln of 1/5 divided by 10, and I get negative 0.1609 t. All right? But unfortunately, that answer's not there. So here's what I do. I get rid of a and d because those have e in it and they have a different value for k, right? So they're clearly wrong. Then what we're going to do is we're going to look at, I'm going to check each, actually, I don't need to check each answer. I only need to check one. So what I do here is I imagine what this number would be, which is 1/10 to the 10th. Sorry, yeah, 1/10 to the 1/10. I said that wrong. And I get like 0.79. And then I see what e to the negative 0.1609 is, and they're not the same because the 500,000 is common to both and the t is common to both. So I'm trying to figure out what this is. So that means the answer is C. All right, so B was wrong, but the CYC works. If, again, when you do e to the negative 0.1609, you get 0.85. And then if you were to do 1/5 raised to the 1/10, that gives you the exact same number. So this part here. So if I ignore the t, that's 1/5 to the 1/10, should give me the same thing as e to the negative 0.1609. All right, so this is how you want to do it, but not, the answer doesn't have to be in terms of e. So that's how you like further kind of investigate to see which one is the answer. All right, number 37. So we have a table. Which of the following must contain a solution to f of x equals 7? So this is just the intermediate value theorem. They tell us it's continuous, and we want to know when there's a specific y value. So this is intermediate value theorem. And yeah, I feel like I'm totally just overthinking this. Yeah, it just has to be between 2 and 4 because when you go from 2 to 4, it goes from 6 to 12. So it has to go through 7. Negative 8 to 2 goes 0 to 6. It could go up and hit 7 and come back down, but it doesn't have to go through 7. And 4 to 5, it goes from 12 to 8. Again, it could go dip below and come back up, but it doesn't have to. It has to between here because you can't skip over 7, because if you skipped over 7, it wouldn't be continuous. But we know it's continuous, and the intermediate value theorem applies. All right, so that one's just B. Be careful of those because they can get you because you just they look like too easy, and that's going to happen. Not every question is going to be super challenging on the AP test. You will have some like that. All right, so the position of an object can be given by these parametric equations. What's the speed of the particle? So the way that you find speed is the square root of x prime of t squared plus y prime of t squared. And then that's evaluated at 4. So we are going to do this. But I don't want to have to do the derivative of those. And this time they give it to us. This time I'm going to do a better job than I did the last time. I learned my lesson. So instead of f and y, x and y, I'm going to use f and g. So I'm going to consider this one f of t and this one g of t. And then we're going to do the whole thing in Desmos. So we go into Desmos, and we are going to define f of t as 4 cosine of pi t over 3. Whoops, over 3. And then we're going to define g of t as 5t minus 3 to the third power, or cubed. And then we're just going to type it in. So we are going to do SQRT. Then we're going to do parentheses f prime of 4 squared plus, oops, I'll do parentheses g prime of 4 squared. And that should be at 4335. Whoops, keep going the wrong way there. Which is answer choice A. All right, so let Desmos do derivatives for you. You don't have to find them, even though we could find these ones. They're not hard, but don't waste the time. Try to let Desmos do as much work as possible to save time. All right, number 39. Table, a bunch of information. Let's ignore that for now. Let's go right to what they're looking for. H of x is given here. What is the value of h prime of 2? Well, let's find h prime of x first and do the quotient rule, and then just be careful, right? So derivative of the numerator is g double prime of x times the denominator minus the numerator times the derivative of the denominator all over the original denominator squared. And then I'm just evaluating them all at 2. So I could plug in 2 here and do the correct notation, but again, we're trying to do this as quickly as possible. So g double prime of 2 is 3, f of 2 is 4, g prime of 2 is 6, f prime of 2 is negative 6, all over f of 2 is 4 squared. Okay, so I'm just getting, I'll go up here, I'm just getting 12 plus 36 over 16, which is 48 over 16, yeah, which is C3. All right. All right, let's move on to number 40. So we're given the graph of the second derivative, and the second derivative basically tells us when the second derivative is positive, the original is concave up, and when the second derivative is negative, the original is concave down. Also, when the second derivative is positive, it means the first derivative is increasing, and when the second derivative is negative, it means the first derivative is decreasing, because the second derivative is the first derivative of the first derivative. So between C and D, this is always negative, which means the derivative is decreasing the entire time. So if it's decreasing the entire time, there can't be a relative maximum. A relative maximum is when it goes from increasing to decreasing. So that can't happen. F is concave up when it's less than A and between B and C. Well, that works because it's positive. When the second derivative is positive, the original function is concave up. F prime has a relative minimum somewhere between A and C. So again, the derivative is decreasing when this is below the x-axis and increasing when it's above. So when you take a look at b, the derivative goes from decreasing to increasing because the second derivative goes from negative to positive. And when the derivative of something goes from negative to positive, it means that function has a relative minimum. So as I said earlier, the second derivative is the first derivative of the first derivative. So that one works. So no, that's probably confusing. It can definitely be tricky. And they usually give you a first derivative graph, but to give them a second derivative graph is kind of tricky here. But the answer is C. All right, let's move on to number 41. So we have a particle moving in the xy plane that has this velocity. Okay. They want to know the magnitude of the displacement. That's pretty tricky because displacement is just where it ended up compared to where it started, and the magnitude of it would just be the absolute value of that. Now, typically that can be very different than total distance. Total distance, you can move back and forth a lot and like rack up a total distance, whereas displacement is just kind of final where you end up minus where you start. And if that ends up being to the left, then you would just take the absolute value of that. But when you have something that where the velocity is always positive, and that just means it's only moving in one direction. So the magnitude of the displacement like is equal to the total distance. And that's important because if we just look at this, e to anything is positive and t squared is always positive. So because of that, we can treat this like a total distance problem. The total distance and the displacement are the same thing. So I can just do that formula. So I can do the integral from 2 to 3 of the square root of the derivatives squared and added. But v of t is the derivative. So it's really e to the cosine t squared plus 3t squared dt. And so we're just going to do that in Desmos. So we go in here and we say, all right, we're going to do the integral from 2 to 3, and then we're going to do SQRT. I'm going to do parentheses e raised to the cosine t squared plus 3t squared dt, and you get a little bit bigger than 19. So 19.006, and that is answer choice C. All right, so the key there is the wording is very strange. Magnitude of displacement, but the displacement and the total distance are going to be the same when velocity is when velocity is positive the whole time. Okay, so let's keep going. All right, so base of a solid of this graph. So if we look at x squared minus 9, that looks like that. Is in the fourth quadrant enclosed by that graph. So we're just looking here. And if every cross-section perpendicular to the x-axis is a square, so if I draw one of these, I know that that ends up being a square. And this length here is this length here. Well, we know that length is the function itself. So this length is x squared minus 9. So what I do is x squared minus 9 squared would give me the area of that square. And then I multiply it by dx, which now gives it this thickness. So it turns it basically into a volume. And then I'm going to integrate from 0 to 3. I took that for granted, but this is clearly 0 because it's bounded by the quadrant. We would have to find this x-intercept. I don't think you need Desmos for that. 3 squared minus 9 is 3. Sorry, 3 squared minus 9 is 0. So you would integrate from 0 to 3. And then this is something that I'm just going to plug into Desmos so I don't have to like square all that out. So I have int. We're going from 0 to 3 of x squared minus 9 quantity squared dx, and we get 129.6, and that is answer choice B. All right, we're nearing the end here. We're getting there. So, what is the average value of h on the interval from 1 to 7? So, the average value is 1 over 6, because this is 7 minus 1 is 6, of the integral of h of x dx from 1 to 7. So that is what we're trying to find. So now let's use the given information to figure that out. Well, they're telling us that the integral of h of x from 1 to 7 is this whole thing here. All right, so we're doing the integral from 1 to 5 of 2f of x. So let's do this. Let's kind of like split this up. So we're going to make this into 2 times the integral from 1 to 5 of f of x dx minus the integral from 1 to 5 of g of x dx. I'm going to have to go down here, plus the integral from 7 to 5 of g of x dx, minus 2 times the integral from 7 to 5 of f of x dx. Okay? So now what I'm going to do is I'm going to take a look at this one and this one. Well, if I do the integral from, if I have negative integral from 7 to 5, I can flip that and make it positive integral from 5 to 7. And the integral from 1 to 5 plus 5 to 7 is 1 to 7. So I really get 2 times the integral from 1 to 7 of f of x dx. And then the same thing kind of happens here. Now I have minus. If I flip this and make that negative, all right, then I can go from 1 to 5, and 5 to 7 is really 1 to 7, but I'm subtracting both. So I'm really doing minus the integral from 1 to 7 of g of x dx. All right, now let's remember all of this is just this part of it. So the integral from 1 to 7 of f of x dx is 6. So I have 2 times 6 minus. Now the integral from 1 to 7, well, the integral from 7 to 1 is 12. Well, this is minus 1 to 7, so if I flip it, then that's just negative 12, all right, which really turns into plus 12. All right, so let me say that again. This minus this integral here is negative 12, because the integral from 7 to 1 is positive 12, so 1 to 7 is negative 12, and minus a negative gives you plus. So that gives us 24, but that again is just this part. So we're really doing 1/6 of 24 to find the average value, which ends up being 4, and that is answer choice C. All right, that was a pretty tricky one. All right, number 44. So we have this function, we have a third degree Taylor polynomial, and we given something about the fourth derivative. Order the following from least to greatest. So the maximum, so this is our error, all right? This is the error from 3.5 to 4, all right? So the way the error works is you're going to do the maximum value of the n plus 1 derivative. So since we have a third degree, they're telling us right here that that's the maximum value of the derivative, okay? And then you're going to multiply by the, let me just write it out. In this case, the center's 4, so it's x minus 4 to the 4th, all over 4 factorial. But we're replacing x with 3.5 because that's what we're given there. So like the max error would the farthest we can go from 4 here is 3.5. So that's why we're plugging in 3.5. 3.5 minus 4 is 0.5. And then again, we're taking the absolute value. So we really end up with 1/4 over 4 factorial times 0.5 to the fourth. I think what I would do from there is just plug that into a calculator, but it's gonna be a tiny number. All right. So if we get 0.5 raised to the fourth divided by 4 factorial, which is 24. Yeah, we get like this tiny number, 6.5 times 10 to the negative 4. So that is clearly going to be the least. I should. Oh yeah, because these are absolute value. So that's clearly going to be the least. All right. So we know that number 1 is. So we're doing greatest to least. So this can't be A or B. Number 1 has to be last. Now I'm going to go to f of 4 first. F of 4, if you think about plugging in f of 4 would just have to be this. The Taylor polynomial has to give you the same answer for both. So plugging in 4 to this, these go away, or just remember that the first part of a Taylor polynomial is f of the value. So that one gives you 1/9. And then f double prime of 4 is, I guess, I would just take 2 derivatives of this. So the first derivative of this is 10 times x minus 4 minus 24 times x minus 4 squared. And then the next derivative is 10 minus 48 times x minus 4. And then if you plug in 4 to that, so again, this is the first derivative of t, and this is the second derivative. And the whole point of all of these is that the derivatives evaluated at the center are the same whether you're using the polynomial or you're using the original function. When I plug in 4 here, this goes away, and I'm just left with 10. So that's 10. This is 1/9. So the greatest is 2, the least is 1, and the middle one is 3. So the answer is C. It goes 2, 3, 1. All right, on to our last one. So we got a region that lies inside one polar curve and also inside the other polar curve. So what you can do here is to get an idea of what's going on. I think what I would just do is I'm going to use Desmos for this. All right, so we want it inside the first one and also inside the second one. So I'm just going to jump over to Desmos for this. And I want to see what these look like. So I have r equals 2 minus cosine theta. And then I have the other one is r is 1 plus. Whoops. R equals 1 plus cosine theta. All right. And what I want is I want it to be the area that is inside both. So that is, if we zoom in a bit, so I need the area that's inside both, so that's this area here. And what I'm going to do is, if I find, it does not give me the intersection, which is quite unfortunate. So what I would do then, I think I would do, no, you know what? I'm going to do the intersection by hand. So I'm just going to do 2 minus cosine theta equals 1 plus cosine theta. I'm going to subtract 1. I'm going to get 2 cosine theta. So cosine theta equals 1/2. So theta is clearly pi over 3. Okay, so that intersection is pi over 3. So I'm going to hop back to Desmos, and the way that I'm going to do it is this. I'm going to find half of this first. I'm only going to find the upper half, the part that's in both. So I'm going to do 1/2 the integral. So this is just how you find the area of a polar curve. It's always 1/2 r squared. I'm going to integrate from 0 to pi over 3. And I'm only going to integrate the first function. Okay? So I'm only going to integrate the red one from 0 to pi over 3. All right? So that is going to be 2 minus cosine theta, squared, d theta. Okay? Then I'm going to do plus. And now I'm going to do 1/2. And I'm going to do the integral. Now I'm going to go from pi over 3 to pi. Because pi, they're basically, so because pi is what's going to get us back to here. All right, so when you think about this, this cardioid, going this way is pi over 3. All right, and then when you go around, what's going to get you back to 0 is pi, because cosine of pi is -1, and 1 plus -1 is 0. All right, so I'm only doing this portion. And then in that one, if I do my 1/2 r squared, that's 1 plus cosine theta. Yes, I realize I have to change that to plus. D theta. Oops. All right. Now what ends up happening is this just gave me the area of the top part, but I want the bottom part too. So then I'm just going to double it. All right. I wanted to write this out for you, but to double it means to just get rid of the 1/2. But the 1/2 are so important as far as like the formula that you use to find the area of a polar curve. But then if I just get rid of the 1/2, that gives me the true area because I'm doubling it. So it's going to be 2.658, which is answer choice B. Okay, that is the end. So I hope you found that helpful to just kind of run through 45 multiple choice problems. So check out again the other video that has the first 30 that are non-calculator. In this video, we did the 15 that are calculator. And again, hope that was helpful.